All right, good morning again, everyone.
Good night.
Good night. Wow, it's been a fast day. Okay, third day, suspension system. We're now going to talk a little bit more specifically about different configurations of our suspension systems. So Tuesday we got into springs and we talked about what suspension systems are going to potentially do. Yesterday we talked about shock absorbers or dampeners and how that is really dedicated to slowing down the progression of the Jounce rebound that's going to affect the different springs, okay? Every suspension system is going to have a spring. Every suspension system is going to have a shock absorber, okay? So regardless if we're talking about torsion bar, McPherson strut, short long arm, there's a spring, you can identify it, there's a shock absorber, you can locate it. Straightforward. So anyways, on your notes, a friendly reminder, blank fresh sheet of paper, okay? You're not continuing on your notes from yesterday. This is brand new. Name up in the top, date is the 27th today, and then we'll obviously continue with this. I do want to remind you I will not be here tomorrow. So when you come in, there will be a substitute, there will be a video that you guys will be watching, and a worksheet to be filling out with that. Okay, it's very similar to what it was like when I was gone back in December, if you guys can remember that. Okay, you will be turning in, or the sub will be collecting the sheets of paper from you, so please make sure your name is on the sheet of paper. And I will be giving you some scores for that in Skyward. Yes?
Can I just not have this back?
Yeah, you'll be exempt because you won't be here, right? Yeah, that's not a big deal. Also, side note, there's going to be a random YouTube link that I'm going to write on the board over here on the side. I'm not going to tell you what that video is, but I'm just going to say I worked really hard on that video. I made it. And you guys can watch it. No, I'll have it up on the board. You guys can do with what you want, because the video I'm going to show you is going to probably take about a half an hour tomorrow. So there might be an extra 10 minutes or something. On your Chromebook, if you want to, you can look that up. I think there's going to be some people that are going to really enjoy my video that I made. There's going to be so many people in here like, that's going to be the reaction.
Boom, 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 boom. Can you do that again?
No. All right, continuing on here. Front suspension system with the torsion bar and springs. Now you don't have to draw this out because we're going to be talking about the different parts component, but here, let's go ahead and identify the spring and the shock absorber in this. Emerson, put the computer away, earbuds out.
Wait, please. I'm literally in the middle of a GeoGuessr game. The Eiffel Tower. Look at it. Look at the Eiffel Tower.
Just so everyone is aware, Emerson is playing GeoGuessr in the middle of my lecture in class. He's also wearing an earbud.
Oh my God, I just got 2.1 miles.
He just got 2.1 miles.
Okay, thank you. Anyone who's watching the VOD later is going to be wondering, wow, this is first hour is off the chains. Put the Chromebook away. Get your notebook out. Thank you. All right. Shock absorber. Where's my shock absorber at?
Right there.
Right here. There's one on this side. There's one on this side. Where's the spring?
Right there.
Right there. Folks, that's the best answer I'm going to get all day. I'm going to say it.
Right there.
Literally, the blue bar. Right there and right here. That's the spring. Mr. Geske, that doesn't look like a spring. Correct. You have to get out of your head that this is the only type of spring that we could be using on a suspension system. No, it's not. You did. You got it right, Gerardo. Good job. Okay? Now, this particular spring is fun because it's lateral, right? It's going to run with the chassis, but it is mounted back here on the frame, and it is connected, it is connected up here to the lower control arm. The red part is the lower control arm. Okay?
Mason. Knock it off.
Guys, calm
Can
down.
you tell your speaker that, please?
No. All right, torsion bars. Sometimes they're called strained out coils because literally what we do is we can take a coil, we take a metal rod and we wind it up into a coil and we create a coil spring. If we were to take this coil and literally straighten it out, that's a torsion bar.
It's crazy.
Okay. Think of it like a hose, right? When you're done using the hose, you wind it up so that way it's small, compact, and you can store it much easier. That's not even a real word. Okay. But then guess what? When you're going to use that hose, you got to wind it out so that way you can reach out where it needs to be at.
We have one of the hoses where like the water like makes it longer.
Yeah, right. You're right. It like extends and shrinks. My wife's got one of those too. She likes it. Okay. I know. I hate it because I like winding my stuff up. It just looks better and neater. All right. Anyways, torsion bar is right here, and we got one right here. We showed you this picture here, I believe, yesterday. Okay. Again, we have one end, this end in particular, that is literally attached to the frame. We have to have an anchor point, so that way, as the torsion bar is twisting, it's not just spinning, right? Free spinning. We need to be able to attach that so that way we can add torque to that. Okay, and again, how do we add torque to the torsion spring? Well, that's from the jounce and rebound of the wheel as it's oscillating up and down as we're driving down the road. Okay, pretty simple when it comes to that idea. All right. Yeah. Okay, again, think of torsion as twisting along an axis. Twisting force, torque. Okay, so it's going to actually add energy and then just want to go and kind of straighten back out. And that's what's going to put the force back of the tire down in the ground. Okay, torsion bars are directional. Okay, when they are made, they actually have a little bit of preload on them, so that way they don't fatigue as much. But there is a left side and a right side torsion bar. So we got to make sure that if you are replacing these, you are obviously purchasing a replacement that is of the suitable size and placement for that. Okay, because again, as wheels move up, they're gonna twist kind of along the different axes. One will be positive, one will be negative. Now, the fun part about this is they are mounted onto the frame here. Actually, it's mounted on the frame down here. This is the lower control arm. The frame's down here. We can actually go in and make adjustments to change the ride height of my vehicle that has this type of suspension system. Okay? Now, with the little asterisk, understand that we're not going to be able to add like 18 inches to the lift of my vehicle. Okay, with this type of suspension system. You're making small changes as the suspension system is wearing and fatiguing over many thousands of miles, and you go and do a wheel alignment. The first thing you got to check is your ride height. If that ride height is not correct, and you have this suspension system, you can adjust that to the correct specification, and then continue with your wheel alignment checks and potential adjustments that are needed. Okay. Again, adjustments are located on various different parts of that suspension system. I'm not going to teach you how to do that. We're not going to get into that. We're more interested in being able to identify that this is a torsion bar and is a torsion bar suspension system.
Does F-150 have a torsion bar?
You're going to have to find out during the lab.
I think it is.
Okay. All right, measuring chassis height. Okay, also sometimes called curb height, trim height, or ride height. This is going to be at specific points on each corner and side of the suspension system. It is manufacturer dependent. This is not universal across all vehicles or all body styles. Okay, so you're gonna have to look up this service information on like Identifix, figure out, okay, this is where the manufacturer has this measurement from the factory. You literally get a tape measure out, and you're going to measure from a particular spot. In this case, it would probably be on the bottom of the lower control arm to the actual ground, or it might be in the middle of your bolt that's bolting the lower control arm onto the frame through that bushing. And again, there are specifications and tolerances that it has to meet to be able to get into WON. Okay? Obviously, if that's too low or too high, it's probably an indication that maybe a bushing or a suspension component has fatigued beyond the point that it needs replacement. Okay? It might look fine, right? You might not notice that it's not performing as it should, but these measurements are a dead giveaway saying This is out of specification. Let's replace that now before it breaks, and let's restore the fully function of that suspension system so it can perform at peak performance. Okay. And again, we have a ride height measurement typically on each part of the wheel, or each section of the vehicle that has a wheel on it, right? Yeah, springs could be broken, sagging, or even need a replacement. Again, that's true for any of the components, bushings, so on and so forth. It could also indicate a issue with the chassis, because again, as we went through the wheel alignment section, if the chassis has been twisted or bent or broken due to a crash or coming in contact with something, that can also change how that operates. It says on the screen that we want to remember to replace springs in pairs, and that some may be position specific, specifically with the torsion bars. But this is going to be true for pretty much for all suspension components. Okay, if I'm replacing a bushing, if I'm replacing a ball joint, if I'm replacing whatever, a component on the suspension system, on the driver's side, it is best practice to also replace the same part on the passenger side. Okay, and there's a couple of reasons why we would want to do that. Okay, first off, if we replace a brand new part on the driver's side but don't do it on the passenger side in this example, the driver's side part is actually going to wear out faster because now all of a sudden it's doing more work because the passenger side is lacking. Okay, you guys probably know this because you probably have group members that you can relate this to. Man, I am like so good at my job and I'm doing this great. I got to pick up the slack of my other group members that are worn out, tired, and broken. Not really, but that's kind of the idea. Okay. Wow, there's some eyeballs looking around right now. That's hilarious. Okay. Anyways, so if I replace, let's say, my driver's side components, I want to replace this passenger side component as well, so that way they are equal in the amount of work that they're going to be doing. Okay. The second reason why we want to replace both parts at the same time is because if this one failed on the driver's side, how much further along do you think the passenger is going to be? They obviously were probably put on from the factory at the same moment. So if this one failed, this one's probably not further along behind either. So again, while you're going in here replacing this part, get this one done too. So that way you're not driving down the road and realizing, oh crap, well, I need to reschedule it to the auto shop or something to get that one done too. Simon?
Are you saying this is like a cost-effective way to not like deal with more further damages?
Yes, 100%. Now, initially you're going to be paying more, right? Because you're replacing two parts, not just one. Okay, but you're trying to save yourself
As much
money on the long term, right? Hey, buy a good quality part. Don't cheap out, right? Because you can go out there and you can buy cheap parts, okay, which is fine. Oh, it meets OEM specifications. No, it doesn't. Okay, I'm just telling you right now. If it's cheaper than the OEM one, it does not use the same materials, and it is not built in the same standard and quality as the OEM one.
The ties work for everything.
Okay, that works for a lot of things. Okay, so my advice to you is buy once, cry once. I gotta buy the $120 ball bearing instead of the $60 one? Yes. Do you know why? That one's gonna last longer. Okay, you get that installed, it's gonna last you probably another 100,000 miles potentially. I'm just throwing numbers out here. Don't throw paper though. If I buy the $60 one, I'm probably going to be replacing that one at the same point in time next year. I've seen it done. They buy the cheap one, next year they have to buy the cheap one again, the next year they have to buy the cheap one again and keep doing that. Now all of a sudden they're spending more money on something they could have spent to buy a good quality part, put it in. Now it lasts 7, 8, 9, 10 years instead of replacing it every year. Okay. You also have to understand the cost of the labor that goes into replacing those parts. Okay. All right, upper and lower control arms. I would probably say pretty much every suspension system that you're going to encounter has a spring, has a shock absorber, going to have a lower control arm. Okay, that's a pretty universal part in suspension systems. Lower control arm. An upper control arm, though, however, is not always present. Okay, it's not always present. It does depend on the configuration of the suspension system. It's not always needed.
Would that be
Okay.
dependent on the spring, or would that be?
It depends on a couple things, right? But you need to be able to look at a suspension system and know what the lower control arm looks like, and then be able to distinguish that between the upper control arm, and be able to identify if it has an upper control arm to begin with. Okay? Now, these thankfully are not difficult to understand. Okay, they're called A-frames in a lot of times, and that's the reason. The reason why is because it looks like the letter A. Okay, like literally. So here and here, I'm going to try to highlight this as much as I can on the screen so people in the back can see this. This is where it is bolted through the frame. Okay, this is where it's bolted to the chassis of the vehicle. Out here, you've got a ball joint. We'll get into ball joints later on, but this is where it is actually mounted to the steering knuckle. Okay, again, we'll get into what a steering knuckle is here in a little bit. All right. So what ends up happening is this A-frame is actually pivoting where it's attached to the chassis, so it's able to go up and down. Yeah. Right, and then my steering knuckle, and then obviously that's where my tire is attached to. So this is how it's able to oscillate, jounce, and rebound, jounce and rebound. Okay. So on this particular picture, my lower control arm is down here because guess what? The lower control arm is lower than the upper control arm.
That's crazy.
Okay, the upper control arm is up here.
Nope.
Right, and that's above the lower control arm. In this particular configuration, both the lower and upper control arms are oscillating like this as the tire is jouncing and rebounding. Okay, you can see here that this is where it's bolted into the frame. We can't see it on this particular picture. You can see two ball joints, so on and so forth. Okay. So, the best advice I can tell you when you're trying to go out and figure out where the lower and upper control arm is, first identify, Jonathan, first identify where the lower control arm is. Okay? Okay, then look above that. If you see another A-frame type component, probably going to be your upper control arm. If you don't see this, it means it's absent. It doesn't mean it's broken or it's not installed properly. It just means that this particular configuration doesn't have one.
Does it normally just assist the lower control arm in its purpose?
We'll get more into this when we get into short long arm suspension systems, but basically it's just there to help keep the geometry and the angles
Fit together.
yes. So that way the geometry is working. That's as simple as I can get into that right now. All right, suspension bushings. Bushings can be made out of many different types of materials, but typically they're a polyethylene or a quote-unquote rubber type compound. These bushings, as you can see in this image, are pressed into our upper or lower control arm. Okay, here's the process of a bushing being installed. We have to press it in. Okay, it doesn't screw in. There's no threads. We literally take a press and we kind of push it in. Okay, you do need specialized tools to be able to disassemble and install a bushing. There's also a very specific procedure on how you would install a bushing, or at least torque it back up onto the chassis. We're not going to get into that right now. But there is some very specific things you must do in order to do this right, not to damage that bushing.
Do you have the tool for
Okay.
it?
I do have the tool for it. This is not something I teach in Auto 1. This is like more of an Auto 2 thing.
Is it a bad idea to use a torch?
Uninstall.
That's what I had to do.
A torch to install or remove?
Remove.
Well,
It's,
removing probably not so big deal. Because
Okay.
the bushing is probably already damaged, and damaging any further is not a big deal.
Maybe installing it may not be great.
I would 1000% not use heat to install my bushing. Okay, anyways, rubber mounted pivots. Our spring in our suspension system is not our only way to absorb energy from the road to prevent that from entering into the chassis. Our bushings are also going to play a small role in that as well. Why? Brand new bushings make a huge difference. Because again, this is where this lower control arm is literally mounted and bolted to the chassis. It is where the pivot point is at. So if my tire is moving up and I've got bad bushings that might be loose, this point here is potentially going to be wobbling around, so it's not going to be as precise and direct in regards to the movement there. It's also going to rattle and potentially vibrate and transfer that force into the chassis much easier. Okay? Now the good news is when you go to inspect your suspension system, get a flashlight, you can actually see these bushings, right? And you can take a look. Are they in good condition? Right? If they look like they're cracked or separated, you need to get replaced. Right? The vehicle might still seem like it can drive down the road just perfectly fine. You're like, oh yeah, this is a fine driving vehicle. You would be surprised at how much better the car handles, sounds, right? And the feeling of the car once you install new bushings. Like, it's remarkable. But you normally can tell the difference unless you install it, because this happens gradually over thousands of miles. Right? So we are very perceptive of this change. That's why periodically, hey, I'm going to rotate my tires. Well, while I have my tires off, guess what? Might as well go ahead and look at my suspension systems. It doesn't hurt. It doesn't take any longer period of time. All I need to do is visually look at it. And I could probably say, oh man, these are looking pretty bad. I might want to take a look at getting these replaced. Or you might say, yeah, they're definitely not brand new, but they still look like they're in decent condition. I can hold off on that. But again, if I start replacing this bushing right here, guess what I should do? I probably need to replace that bushing as well. And while I'm at it,
The other side.
let's do the other side too. Okay? Just throw that out there. Simon, question?
Why most people don't get their bushings replaced is due to the labor.
It's due to what?
Some of the labor.
Potentially. Now, here's the fun part, right? Now, back in the day, you pay someone to do this and they'd have to manually go in and they could do it. Nowadays, parts are so interchangeable, it's almost easier and cheaper, quote unquote, less expensive, to just buy a whole brand new lower control arm with the new bushings installed. Because then you got new bushings, you got a new ball joint, new control arm. You literally unbolt the lower control arm, put the new one in, boom. You don't need those specialized tools. You're paying more for the part, but you're paying less in labor.
Yeah.
Just throw that down. Now, if you can do this on your own and you have the tools, save yourself $1 or $2. Just buy the bushings, and you can do that on your own, right? It's definitely cheaper to do it that way. But if you're going to pay somebody else to do it, it might just be easier just to buy a new part. I know that seems kind of ridiculous, but that's just kind of the way that the market is right now for aftermarket stuff. Okay, control arm bushings are pressed in and out of their bores with special tools. There are bushings on A-frames, strut rods, and sway bars. You probably want to make sure that you are identifying where bushings are at, what components have bushings in my suspension system. Probably something important. And again, I want to emphasize this. There are different quality of bushings. Okay? Again, it all depends on what you want to achieve from your suspension system. Hey, I want a stiffer suspension system. I don't mind feeling the extra road vibration because I'm more interested in performance. That's awesome. You can go out and find a very hard bushing that's made for that purpose. It's going to have all the vibrations from the road. It's going to be able to be way stiffer. Okay? It's not going to rotate as easily in the lower control arm or the strut rod or the sway bar, whatever that may end up being. Cool. Okay? Or hey, you know what? I don't care to have a stiffer ride. I'm not going 80 miles an hour around a corner. I want my ride to be much smoother. I'm driving for thousands of miles every week. I want a comfortable ride so that way my back isn't damaged at the end of the day. You look at the different quality of bushing. You might want to get a softer bushing with a different material that's going to absorb more of those road forces, more of those vibrations. They allow the suspension system to actuate maybe easier. It might not last as long, but maybe to you the comfort is more important.
Screw you, Chris.
Okay, so again, I'm just kind of going out there to let you know this goes deeper than what you might think. Okay, and there's a lot of choice when it comes to what parts and components you're replacing and how you replace them and all that sort of stuff.
Oh, okay.
All right, when we do install our bushings into our lower control arms or our sway bars or whatever that may end up being, okay. When we are, here's one of these press tools, by the way. Oops. Here's one of these press tools. Okay, so we're using an impact to basically run this in, and it squeezes that in. To help aid that bushing being installed, because we don't want to tear it, we don't want to rip it, because that would ruin it, we're going to use some silicone spray in order to aid the lubrication of that going in and installing correctly. We want to use silicone spray, silicone lubricant. We do not use petroleum-based greases. Okay? Anyone have an idea why we do not use a petroleum-based grease?
It'll eat away at that.
Yeah.
The petroleum-based grease or lubricant will actually eat away at the bushing material. Okay? Because this stuff is made out of a synthetic rubber type material, it does not interact very well with petroleum-based products because it basically is made out of petroleum-based products. Silicone will not do that. That's why we use silicone. Okay? How am I doing on time? Pretty good. All right, here's some pictures of some good bushings and some bad bushings. Actually, these are probably a bunch of stuff. Okay?
The bushing.
That's a bushing.
That is not.
It's a different style of bushing. It's a vertical. But you can see here I got these little tiny micro cracks. Yeah? Okay? That's from stretching. It's from that material hardening over time. And it's stretching and it's kind of tearing itself apart. Okay? Here are a couple bushings that have been separated. So I've got my control arm or whatever this particular part is. It's made out of metal. My bushing has a metal pin on the inside here, whoops, that my bolt is going to go through. All right, and then from here I've got my rubber, synthetic rubber material that is going to twist and bend. Okay, so again, that's going to twist and bend as that lower control arm is moving up and down. Again, over a period of time. Oh yeah, look at that. This thing is going to tear. You can see here I've got tears right here. That material has been separated. Guys, shut up, please. It's really annoying. Especially when other people are trying to pay attention and learn. Thank you. Thank you. It's embarrassing that I have to tell you this at a high school level. All right, here we've got some stuff that's beginning to separate as well. That's obviously things that you, when you're inspecting, you're looking for. You're looking for these gaps in between the metal of my bushing. I'm looking for these small cracks along those lines, separations. Again, here we've got a nice bushing. It's in good condition. If I'm inspecting that, that's good. I can check that off with confidence, knowing that that's still
There's a chunk out of that piece.
good to go. What? No.
Yes.
That's just the way it's designed.
That was broken. Boy.
I'm not saying. Sometimes you might actually have like specific holes in it.
No, like up top. Just put your finger on the screen. Okay, higher. Towards yourself a little more. Like right there.
Right here?
Yeah, like that looks broken off.
Oh, no, that's part of the mounting part on the frame. So here's my, come on, there we go. So here's my here's my lower control arm, right? This part here is part of the chassis. And then here's my bolt, and it goes down here.
This looks broken.
It might look broken. It's probably just the angle of the picture. So.
Ow.
All right. All right, the steering knuckle. The steering knuckle is essentially where everything comes together and is mounted onto it. You're not helping me, Juan. Jonathan, that also applies to you. You're not helping me.
Attention all Final X students and staff. At this time, please head to the northwest side of the H by the Social Studies pod to help cheer on and send off our wrestlers who are participating in the WIA State Wrestling Tournament. Thank you.
I'll go to that. I'll support that.
Let's stay in.
Yeah, we don't want to.
Okay, this is going to be our last slide. We're going to give you guys 5 minutes at the end of class here to write down any questions that you might end up having.
Are we not going?
No.
I'm not planning on it.
By the time we get down there, they're
I
already
want to go
walking.
though. I want to go show my love.
Apologies if you
Yeah.
wanted to go down there.
Jet ski.
I want to go.
Okay, steering knuckle.
Oh my gosh.
Steering knuckle, this right here is where our lower control arm is going to be attached. Up here, on this particular steering knuckle, is where our upper control arm is being attached. This little spindle hub is where the wheel bearing is going to be installed, and this is ultimately where the tire is going to be attached. Okay? This is one example. Here we got a little bit of drawing. I've got my steering knuckle right here. The steering knuckle is where my brake caliper is attached to. Again, my wheel bearing, my rotor, my wheel hub, which has my lug studs, which is obviously bolted onto the wheel. It's going to have my shock absorber. In this particular case, actually it's a strut. I'm still going to have a lower control arm down there as well. Okay, again, here's another picture here's the wheel hub. The axle goes through the center hole, my steering knuckle. Okay, again, I'm going to have my lower control arm down here. It's not going to be drawn very well. I'm going to have my upper control arm. I'm going to have my tie rod. Okay, the steering knuckle is actually not only a part of the suspension system, it's where the steering system is attached to as well. Okay, and the steering knuckle is going to rotate with the tire to allow for steering in the front wheels. It's going to actuate up and down with the suspension system, so on and so forth. Okay? Okay, at this point in time, we've got about 5 minutes left in class. I want you to open up your notebook, and I want you to spend the next 5 minutes writing down at least 3 questions. I know you've got at least 3 questions. Okay, on the back side here. What did not make sense to you today? What did I not explain clearly to you today? Okay? Maybe you have questions in regards to the springs or the shock absorber in relationship to some of the parts that we're talking about today. You know what I mean, Easton?
I know exactly what you're talking
You can put your notebook on the table, it's okay. And then your phone can go in your pocket. There you go. Thank you. All right, what kind of questions might you have for me? What questions do you have for yourself?
Why didn't you
Right on the presentation recording here.
He's gonna stab me.